Hello dear students, welcome back to my YouTube channel. This is my third video on thermodynamics. In this video we will discuss about the pressure volume work done, first law of thermodynamics, zeroth law of thermodynamics, state function, path function, and work and heat equivalent. So first of all we will discuss about work. We can change the internal energy of the system by doing some work. Work is just another kind of energy. In work can be mechanical, electrical, gravitational, but in case of thermodynamics, we usually discuss about mechanical work done, which is related to pressure and volume, which means that work can be of expansion and work can be of contraction. So, mechanical work. Mechanical work is actually the work done when we apply some force to an object and it gets displaced to a certain displacement. The work in that case will be equal to force into displacement, and integration of that force into displacement over the whole line gives us the total work done. So W will be equal to F dx integration x node to x. Here the total displacement x node is our starting point and x is our final point. So as we know that force is equal to pressure into area, or we can say pressure is equal to force upon area, means pressure is force acting on per unit area. So we will substitute the value of force here with PA, pressure into area, and dx the integration of dx gives us x minus x node. Now area into total displacement gives us the total difference in the volume, that is how much the volume has been increased or decreased. So work will be equal to minus P delta V or minus P dV. When there is work of expansion, that means volume has been increased, then the work will be equal to minus P delta V, means work is negative or work is done by the system. When there is contraction, it will be plus delta V, plus P delta V. We will use plus P delta V, the work done on the system, which is known as work done on the system. Then what are state functions and path functions? In thermodynamics, the state functions are the functions which depends only on initial and final position. These are independent of the path followed. Suppose we have increased the temperature of some liquid by applying heat. We can also change the temperature by doing some mechanical work or stirring. So the total difference will remain the same in both the cases. We have reached that final temperature by applying some heat or by doing some mechanical work. That difference delta T will be same in both the cases. So temperature is state function in that case. But the path function, these are independent of the path followed. These just depend upon path. The path functions depend upon the path followed. This does not depend upon the initial and final position. There are certain examples of state functions. The change in enthalpy, change in Gibbs free energy, change in volume, change in temperature, these all are state functions. And in case of path functions, work and